So with our ocean currents, the biggest thing we need to understand is that those convection cycles are happening just like in that pot of boiling water, like in that hot air balloon. Those convection cycles are happening in the ocean, but right, we have two hemispheres of our earth. So we've got to get away from saying they go up and down, up and down. They're still doing that, but we need to start using the words they equator and poles, equator and poles. So here, let me grab, my head is in the way. Okay, so here is our equator line, and every time it's getting hot, it's traveling to the poles. And now it's doing this in all these cycles all around. I'm just going to draw one big one so we can kind of understand the point of this. So the hot goes to the poles, or it travels away from the equator. It means the same thing. Away from the equator is going to the poles. Right? Then once it gets to the poles, we know that's not getting as much sunlight. So it's going to be colder up there, and that water is going to cool. It's going to come back together. It's going to get colder, and it's going to sink back down to try and warm up. So now it's coming back down. And then this is coming back down. So we can't just say up and down. We're saying hot goes to the poles or away from the equator, and then the cold goes to the equator because it wants to warm back up, and that's where it knows it can warm back up because that hot is leaving, so it can go in and take its place. And then, so it can go to the equator or away from the poles. So we've got to understand that it's that mirror image. It's happening double. So we can't just say up and down. To the poles, to the equator, to the poles, to the equator. So we've got to get that language going. Otherwise, I might have to start doing a really terrible dance for you. Nobody wants to see that. So start using those words, right? To the poles, to the equator. Hot to the poles, cold to the equator. Hot to the poles, cold to the equator. Okay. One thing, be sure to notice that this is the Gulf Stream here. That's a really important little stream of water here that you will learn more about in one of your next lessons, but just kind of note where that is. It's just on that east side of the United States, and then kind of goes on up over here toward England. So let's take a look at a few of these places. So we're going to compare Los Angeles, which is right over here, and we're going to compare it to Charleston's, so right over here. So just they're very similar in their latitude. We're going to compare opposite sides of the United States. So in California, we've got this cold current coming down. So we think, oh, beach in California, it's actually even in the summer, very cold, kind of shocking to get in the ocean in California if you have ever been there. However, on the other side, we have this warm, because this water is going down. It's coming down in this cycle. So it's been up high and it's coming down from the poles. Cold water, okay. Yep, not getting in it, okay, right? But over on the other side of the United States, it's coming up from the equator, and it gets this nice warm water. So if you want to go to the beach like this in the United States, this is the side of the United States you want to go to. So Charleston is going to have much warmer oceans because of where it's coming from. Okay, so let's look at Cartwright, Canada. So that is here. So I kind of lost my arrow. Whoa, that one got a little crazy there. So Cartwright, and then we've got Westport, Ireland. So again, those similar latitudes, you would expect them to be very similar. However, Canada has this cold water coming back down. So it's staying very cold all the time. Where Ireland, even though, these are pretty high north in their latitude, but this Gulf Stream, let me grab a red pen and keep that Gulf Stream red, is passing by Ireland, and it's keeping that nice and warm there. I mean, it's not tropical by any means, but it's much warmer than over here in Canada, even though they're the same latitude and distance from the equator. Over here is going to be much warmer because that warm stream of water is carrying all that warm air with it. Okay, let's look at Westport. So we've got Westport, Ireland, and Trujillo, Peru. Now, this is an interesting one. So Westport, right, has this warm Gulf Stream going near it, and Trujillo has this cold stream coming back to the equator. However, look how, so even though it's cold, look how close Trujillo is to the equator. It doesn't matter, even though it's cold. Like at this point, right, the water's starting to warm up. And at this place, it's still going to be much warmer just because of its proximity to the equator than Westport, Ireland. So right, this is just a colder, like it's a little bit colder, but it's still going to be much warmer because it's close to the equator. It's starting to warm back up, right? And it's warming up and then it's already warm again here. So, right, this is, even though this is blue, it's starting to be red again. Okay, and then let's look at Los Angeles and Westport. So again, Westport has a higher latitude. So, however, it has that red warm current going up. And California is going to have this cold one coming down. So, right, California is generally sunny, but just that water is not going to be as warm there compared to this water here. So that water just can really make a difference of, is it going to be a cold coming across? Is it going to be warm, right? So when our wind blows across here, we're getting a cold water coming across here. It's been cold and it's coming across. So that can definitely affect our temperature even in Utah, even though the ocean is not anywhere near us. So if you want to find Mrs. Richards, you'll find her, you know, right over here on this side of the United States, nowhere in the water over there. So just think about every time you got to double that mirror, and warm is going up to and down to the poles. So up and down, right? It's going to the poles. And then the cold water comes back to the equator to warm up. So it's making this double cycle on both sides of the equator.